Hi, Miss Knight. For this video, we're going to be going over volume of a solid of revolution. And we're going to be looking at many ways you could go through volume of revolution. So volume of revolution is the same thing as many things as Langerl. It can go on the x-axis or the y-axis. And that can also cause problems when you try to find the volume of revolution. So volume of revolution also comes in two different things. It comes in disks and it comes into washers. So disks, for example, have the formula of A equals A B integral of just hijack fx, or it could be fy. Well, that's just finding the volume normally. If you were to find the volume of a disk, well, that's the area, but the difference from area to disk is you square it. And then the difference from disk to washer is you have two different points you have to subtract from each other. So I'm going to say W, or in this case, volume, and I forgot the pi for that one, equals pi. And then I'm going to show you dc for the y-axis, of course. gy, which gy will always be the farthest from the axis of rotation, squared minus fy squared. That's washers. So for washers, if, say, I'm just going to use the example of, we have the equation, you can see this, x squared and we're going to have it about the line x equals -1, and we're going to have the rotated piece be from 0 to 2. So it's going to be rotated pieces in here. It's going to rotate around the dotted line at x equals -1. So for this, because it's rotating this way, you're going to have this inner piece and this outer piece. So you can see it's a washer here. So this is going to be a washer equation. And for this, you're going to need to find here to here, which is 1, and here to here. And then because it's y, this is going to be square root y. So you're going to get the equation. You can also substitute these for r squared minus little r squared. And you can also find distance from here to here. The farthest thing is this line, and it's 3 away from the axis. So you're going to do 3 squared minus 1 plus square root y, because it's x-axis, squared. And you're going to integral that from -1. Sorry. From 0 to 4, because it's on the x-axis, not the y-axis. I got confused there. It intersects at 4 and 0. So that's why you would do 0 and 4, because you're looking for the y-axis. Jake, you cannot be in the video. No. No. You're already loud enough. Sorry for the cat, Mr. Knight. And to solve this equation, you would take the integral, which what you would get would be 9 minus plus 1 square root y plus 1 y squared to plug that into your calculator. You wouldn't actually do that. And you get the area. Then if, say, you're doing this for this x-axis, it would instead just become a disk. And you would just do the equation of x squared, and you would just do it from 0. Or if it's, you want to do it around -1, which wouldn't do much for the x-axis. If you're doing about y equals -1. Sorry if this is too much work. I'm gonna y equals -1, and then you kind of just shorten the washer, mini washer. You just do x squared, and this would just go from 0 to there too, I think. That's just disk. Obviously pi. Keep forgetting pi. My bad. I'm in Pi Club and I forget pi. Alright. That's how you set up limits of integration for volumes of a solid. Mostly this equations, I've even used this when 3D printing. Very useful in the real world. Thank you for watching. Sorry for the cats and the other background sound. The cat just wanted outside.